Okay, let's do some problems about factoring. So I'm going to start off with 2x squared minus 9x minus 5. So when I see a quadratic like this, the first thing I'm going to do is make myself a template. So here's my template. I feel better as soon as I see the template because I see the path before me. So we're trying to undo a foiling. Whatever we had here, we foiled it and it became this. So you know that your x squared term always comes from the f in the FOIL. So we're going to have something times x here, something times x here. Those two things multiplied together need to give us 2x squared. So what could we have had? Well, it must have been x and 2x, or 2x and x, whichever order you want to write that in. Okay, so we're like reverse engineering this foiling. This is how we got 2x squared from 2x times x. All right, and now what we want to do is figure out what we would have had to put in the last place in both of these parentheses. So for your L in your FOIL, last times last, that would have given us negative 5. I'm not going to worry about the negative part yet, but I'm going to focus on the fact that it was 5. So I need something times something to give me 5. That could only be 5 and 1. I mean, unless some diabolical person was using square roots inside parentheses here, it must have been 5 and 1. The problem is, I don't know, should I do 5 here and 1 here, or should I do 1 here and 5 here? I have to think about trying both ways. And what I'm going to use as my basis for comparison is what would I get for my O and my I when I do the FOIL? Can I get 9 over here? So I'm just going to try one way, and if it doesn't work, then I'll try a different way. So let me try putting the 1 here and the 5 here. And I'm still not putting the sign yet. But for my O and my I for my FOIL, my O would be 10x, and my I would be 1x. And I think as long as I do 10 minus 1, I can get 9. So that might work. But if I'd done it the other way around, if I put 5 here and 1 here, then my O would be 2x and my I would be 5x. 2x and 5x cannot give me 9x. Even if I add them or subtract them, I can't get 9x, right? So that's how I know to put 1 in the first parentheses here and then 5 in this one. Okay, so with 10x and 1x, I think I can get 9x. Now I just have to make sure to put the right signs. So this 1 and this 5, the L from my FOIL, needs to give me negative 5. So 1 must be positive and 1 must be negative. And then I look at my 9x here, it's negative. So I think what I want to happen is I want 2x times 5 to be negative. So I'm going to put the negative there so it's on the 5. And then I'm going to put the positive here so it's on the 1. If you mess it up, just check your work and then switch them. So now when I do my FOIL, my outer is going to be negative 10x, and my inner is going to be positive 1x. And that's going to give me my negative 9x over here. So last step is always just FOIL it back out and make sure you get the right thing. So first, 2x squared, outer, negative 10x, inner, 1x, last, negative 5. And this is indeed what we started with. So this was the right factoring. Okay, let's do another one. So in this one, I see a 4th power, and that puts me a little bit on edge already. So I hope I have some tricks up my sleeve, because I really only know how to factor quadratics, and I have a PhD in math, so nobody really knows how to factor much higher than a quadratic. Maybe some people can do cubics. There's a thing called grouping. This doesn't always work. Okay, but for something like this, and if it had applied to the first one, I also would have done it there. You always want to take out any common factors that you see. So in this problem, I see that there's a 3 coefficient here, and then 24 also has a factor of 3. So it's 3 times 8. And then both of these terms also have an x. So I'm going to factor out 3x. So what does that leave me with? So what do I have to multiply by 3x to get 3x to the 4th? X cubed. And then to get negative 24x, I need negative 8. Yeah, that should give me negative 24x. And now I hope you can see that this is actually the difference of cubes. So this is 8 is 2 cubed. So now we can apply the formula for factoring a difference of cubes. So if you have this memorized, or if you have if your teacher gave it to you, so a little sidebar here: a cubed minus b cubed. There's a formula for this, and the formula is, oh, I may not have enough room. I'll write narrowly. So this is a minus b times, I hope I remember this right, a squared minus ab plus b squared. Nope, I remembered it wrong. This is a plus. Okay, so this is the formula for factoring difference of cubes. So we're going to apply this, and my a is going to be x, and my b is going to be 2. So back over here, 3x is going to stay in the front, and then I'm going to have so a minus b, so it's going to be x minus 2. Okay, and then I'm going to have a squared, so that's x squared, plus ab, so that's x times 2, so 2x. And then plus b squared, so that's 2 squared, which is 4. Okay, so at this point I've factored it mostly. The only question is, like, does this factor anymore? So we could try to factor this. Let's see, so we'd have to do x and x, and then we could either do 4 and 1 or 2 and 2. So if I do 4 and 1, I get 5x, or sorry, I get 4x, and then I get 1x for the outer and inner, which would give me 5x. So I could do 2 and 2. I don't think that's going to work either, because that's going to give me 2x and 2x for outer and inner, which can't combine into 2x. So it doesn't look like it's going to factor into integer factors. It's always possible it could factor into something with square roots, but this would probably be where I would stop, unless you've learned how to factor using the quadratic formula. I would not normally have taught how to do that at this point, so I would stop here. You could at least use the quadratic formula to check. Well, I guess, I mean, it depends again on like how well you know the relationship between the quadratic formula and factoring. There could be some ways to check whether this has any factors. But I will stop here and let's do the next example. Okay, so we have 2x to the 6th plus 4x cubed plus 2. So again, I see the high power on x and I'm like, I don't know about this. But let's go ahead and factor out anything that's common to all of the terms. So I think they all have even coefficients. So I can take out a 2, and that leaves me with x to the 6th, 2x cubed plus 1. And now that you look at it like this, I hope it looks a little more like one of those special factoring formulas to you, because this is actually, the special factoring formula is this one. So a squared plus 2ab plus b squared factors into a plus b squared. So I know it doesn't look quite like that, but that is actually what's happening. So the thing that we're using for a here is x cubed, and the thing we're using for b is 1. So if you plug in x cubed for a up here, you get a to the 6th. And if you plug in x cubed for a here and 1 for b, you get a cubed. So x cubed, 2x cubed. So that's this. And then if b is 1, then b squared is 1. So that's this. So it's a little bit tricky to see, but that is what's going on. So the factoring here is 2 times x cubed plus 1 squared. And if you want to double check, you could FOIL that back out and make sure you really get x to the 6th plus 2x cubed plus 1. Okay, let's do one more. So the last one is x to the 5th minus x. Again, a scary high power, but let's tackle it. So the common factor here is x. Let's take out x. That leaves us with x to the fourth minus 1. Okay, so now I hope you would see that this is difference of squares. So the difference of squares formula is a squared minus b squared factors into a plus b, a minus b. So here, my a is x squared, because x squared squared is x to the fourth. So maybe if I write it like this, it might help. So this is x squared squared minus 1 squared. So that's the difference of squares. So to factor difference of squares, we add the two things being squared. So this is going to be x squared plus 1. And then we subtract the two things being squared. So x squared minus 1. And now we factored somewhat, but we could still factor more. So I already know this one's not going to factor x squared plus 1 because I know if I graph this as a function, it never touches the x-axis. It has no roots, which has to do with factors. If you didn't know that, you might wonder if you could factor it. But the second one here, you definitely can factor this because it's the difference of squares again. But now it's different things being squared. So the thing being squared here is x, and the thing being squared here is 1. So this is x plus 1, x minus 1. And that's where I would stop.